This video is going to be about how we can address or work around database deadlocks from .NET client-side code. Database deadlocks are hard to troubleshoot, and I think that's an understatement. There are other types of deadlocks that you might encounter in applications where threads or processes attempt to simultaneously access the same resources in an unfortunate sequence where each is waiting for the other to release a resource before proceeding. I am not going to describe deadlocks in this video. I'm going to assume you know what they are. Deadlocks can be analyzed by a variety of techniques, which will also not be discussed in this video. There are blocking conditions in SQL Server and other applications that are not deadlocks, and the approach described in this video does not address those blocking conditions. We're going to start with the assumption that you have a single deadlock situation which must be resolved quickly. If you're encountering many deadlocked scenarios in an application, you might do much better to fix the root of the problem. We're going to assume that you're unable, unwilling, don't have time, whatever, to analyze the diagnostic resources provided by SQL Server to understand why the deadlock is occurring, that you want to address the deadlock in client-side .NET code. Although we're going to be looking at actual transact SQL statements that are sent from the client to SQL Server, this will work equally as well if a stored procedure is being executed from client-side code, where we have no understanding of what server-side code is executing, but its execution results in a deadlock. The approach is therefore not dependent upon the exact details of the deadlock, but we need one for demonstration. It shouldn't matter too much how the deadlock is created, but we do need to be able to create a deadlock. The code I'm using to generate a deadlock is based on code from pages 427 and 428 of SQL Server Query Performance Tuning Distilled from 2004 by Sajal Dam. Looking at Amazon, I see the book has been updated several times by him and a co-author, Grant Fritchie, so I'm going to have to get a newer version. But I suspect most of what I see in this book is still applicable. This is a very good book. I recommend it. It has many simple examples where you create demonstration tables, look at execution plans, and it really does a great job. This demonstration is not going to discuss how to analyze deadlocks and prevent them with transact SQL code. The whole idea of the demonstration is that we want to fix the problem on the client side without understanding any of that on the server side. However, I think it makes sense to look a little bit at the code that we're going to be executing on the server side, which creates the deadlock. We're going to be creating a table called T1, and because we may want to run the script that sets up our environment more than once, we're going to start off dropping the table if it exists. I'd like to point out something about the Go batch separator. Go is not a SQL Server keyword. If you send the word Go as part of a batch to SQL Server, you will get an error. And the reason is because Go is a word that is recognized by Management Studio. It is a batch separator, and you could make it some other word if you wanted, so long as it wasn't a keyword or a word that you used in the schema of your database, and that would work just fine. That is going to have a consequence later on. Once we make sure the table doesn't exist, we're going to go ahead and create it or recreate it. The table is going to have 2 integers and 2 character fields. We're then going to create an index and insert a row into it which contains 2 integers, and the 2 character fields are going to have empty or zero-length strings in them. We're then going to select from the table to see that it really did what we expected. After the table and the data row are created, we're going to create an update trigger. We're going to put a delay in it because when I get executing scripts against this table, I have to have time to run scripts on 2 separate threads, otherwise we're never going to get a deadlock. What happens when we update T1 is that it is going to change the modifier column to the username associated with the session or connection on which the update statement is running. Here we see that we're only going to update the row that was updated in the cause of the trigger firing. So we're really going to have 2 updates running. When the update occurs, the update will occur in the record. then the trigger will fire that will update the same record again and update the modifier column. Because the trigger is modifying the record which causes the trigger to fire, you might be wondering if this won't recursively cause the trigger to fire an infinite number of times. Let's look at the property settings for the database we're working with. If we go to Management Studio, right-click on the database name, and then select Properties, we come to the Database Properties dialog, and then select the Options page, and we see there are two similar but different properties. One is nested triggers enabled and the other is recursive triggers enabled. Nested triggers means that one trigger can fire some other trigger when it modifies a record that affects a table that has a trigger. The recursive triggers is the situation we're looking at here, where a trigger makes a modification that would call itself to be fired again. Notice that by default recursive triggers is false, but nested triggers is true. This is a database by database option, not an option that is set for the instance of SQL Server. After we run this a couple of times, the trigger is going to keep changing the modifier to the same value, the username. But that really doesn't matter. We don't care. The trigger will fire and we will have the situation we need for our demonstration. Once we have it set up, let's go ahead and set it up now. We'll see that we get the values we expected with two empty strings in the row. We have to have something that's going to cause the deadlock. So we're going to run the same statement on two separate threads. In this case, it's thread 63, or SPID 63. SPIDs aren't actually threads. And 67. Those are actually sessions. And notice I've already run this once before, so pretend you don't see that. If I run them separately, we'll see that after about 3 seconds, we see the values. It has been changed from what we saw on a previous screen. So we see the A value, and then the modifier is the database username associated with the SPID. If we run it here, we go ahead and, not too surprisingly, get the same result. But because of the way things are set up, if we run them virtually simultaneously, we're going to get an error. SPID 63 is going to succeed. SPID 67 is going to fail. It's going to say there was a deadlock on a resource with another process, and it selected this SPID, server process ID 67, as the victim and killed it. There would be a way to address this on the server side, which is not really a solution to the deadlock problem, but let's look at this. What we're going to do is create two integer variables, one for a deadlock counter, the other for a loop counter, and we're going to create a loop that is going to execute at most 10 times. When we enter the loop, we're going to set the loop counter to 1 so that each time we go through it, it will increment and eventually the loop will end, even if the code never does what we want it to do. We're then going to use a try-catch block and put in here the same code we saw that we were running before. We're going to try to make the update, but if it fails, it is not going to get to the break statement, which would drop it out of the loop. It's going to go to the catch, increment the deadlock counter, print a message in the messages screen that tells us what the deadlock counter is, and then it's going to continue to loop again until either it succeeds and the break statement executes, or it fails 10 times. Then it's going to show us what happens here. Let's try running this by itself. Without competing with any other SPID. Okay, after about 3 seconds it executes. What happens if we execute them roughly at the same time? I can't click on them both at the same time. That's why the wait for statement is in the trigger. And we'll see after about 3 seconds, SPID 63 completes. After a little while, we're going to see that SPID 65 completes, but we get a message telling us that the deadlock counter incremented, and so it went through this loop twice. Now you'll notice that it says multiple rows are affected, and that's because we had more than one update statement involved. And this is very common in triggers because we're actually executing multiple SQL statements. Now this is not a solution to the deadlock problem, except in a manner that we might describe as a workaround. We haven't figured out why it deadlocked. We haven't done anything to fix the deadlock. We've just said that this SPID is going to keep executing until it succeeds or fails a number of times. Actually, I would probably want to put this in both places because I just happen to know which one I executed first. And we'll see if we do that, we should be able to execute them in either order. And have it succeed where the second one I start actually fails. The rest of the demo is going to assume that we don't want to fix this on the server side. Maybe we don't know how to write T-SQL code. Maybe we tried to figure out why the deadlock was occurring and fix it through T-SQL and we couldn't. And we're in a situation where we have to fix this. So we're going to look how to fix it on the client side. I have created a .NET application using C# where we're going to see if we can execute these scripts. It would only be necessary to execute the second one from this code in order to demonstrate the code. But I went ahead and wrote it so that we do it all from client side. Let's look at what happens. If we click on this button, it is going to open a window called First Connection Operations. And we'll see one button is going to do what we saw in the setup code, and the other one is going to run the update command. Now here's where it is a little bit interesting, because we run this code, we have a data grid on there, and when we click the button we want to make sure everything looks kind of pristine, so we're going to clear it out if it already has some data in it. Then we're going to execute application do events, because as it turns out, we can set this data source to null, but due to the way messages are passed within Windows, it may not do it right away unless we tell it, yes, update your user interface right now. Then we're going to create a connection object after we went ahead and included system.data.sql client in our using statements. I'm going to come up here and tidy things up. Say, just show me the ones I'm using. We create the connection and we open it. Possibly there should be some error handling there, but the purpose of this demonstration is to show some concepts, and so you might do some things in an actual production application that I'm not doing here. Now the next thing we're going to do is create a string, and here is a feature of C# I really like. If I put this @ sign before the double quote, I can go ahead and put a formatted SQL statement in here without having to concatenate a bunch of things together. This is just wonderful. I love it. I use it all the time. Notice that I don't have any go statements in here because, as I indicated, go isn't going to be accepted. So the things in the go statements are going to have to be executed in separate command executions. Then we're going to have a string that creates the table, the index, inserts the record, and then we're going to have one that creates the trigger. For no particularly good reason, I have not included the select statement that returns the initial record that is inserted. We come down and create a command object with the first SQL statement and executes it. Now we could create separate SQL command objects for each of those, but really all we have to do is change the command text and execute the same one over and over again. So this is going to do the setup that we saw in our original setup script. Then the other button is going to go ahead. It's also going to set the data source equal to null because we may just run that first button once. That's all that should be necessary. We'll do events, we'll make a connection and open it, and then we're going to put our update statement and select statement in the string for SQL, again using this very wonderful @ operator so that we can just put a formatted statement in there. VB.NET doesn't seem to have a similar operator, unfortunately. Because this is returning data, we'll create a data adapter, a data table, fill the data table from the data adapter and set the data source of the data grid to the data table. Let's go ahead and see how that works. Here we go ahead and see some things. We know they're happening from the output window. We really don't get any output here. And then we're going to run the update command. And after about 3 seconds, we should see something in the data grid view. And we do. Now, we're going to go to another form. And we're going to run code on another connection, another SPID. And now let's look and see what will happen on the client side under circumstances similar to what we saw in our T-SQL code executed through Management Studio. We're going to start out without any error handling, and we're going to open a form called Form Without Error Handling. We're going to have a Run button, and we're going to again set the data source of the data grid view to null in case we run this more than once. Have application do events, create a connection, open the connection, and then execute the code exactly as we saw it in the original scripts. We'll go ahead and create a data adapter, a data table, fill the data table, and then set the data source of the data grid view to the data table. Now, in order to demonstrate this, I actually have to have both forms open at the same time. The form that runs what is essentially connection 1 and this one. But because the forms application is essentially single-threaded, if I do that, I get a result that doesn't help me very much. If I go ahead and execute this code and then execute this code, what really happens is that the code from the form on the left executes, and after it completes and after the trigger fires, the code on the right executes. So I really need to execute 2 copies of the application at once. I could use some background worker threads behind the button so that this would become a multi-threaded application and I could do everything from a single form. But that would introduce some unnecessary complexity, and so it's just going to be easier to run 2 copies of the application. I'm going to take a version that I have saved outside of Visual Studio and execute it. It will be a separate application. It will have its own threading, so I can run this copy of the application and then run this copy of the application, and I won't have this blocking situation that comes from the application being single-threaded because it's 2 applications. So let's go ahead. We have our startup form. We don't need to run this again because the record that we're going to be trying to modify already exists. Let's run them separately. After about 3 seconds, that will succeed. After about 3 seconds, this will succeed. But let's see what happens when we try to run them at the same time. Well, we get a runtime error, and because we haven't handled it, our application essentially crashes. We get different SPID numbers this time. We get this error that it was deadlocked on another process, and this has been selected to be the deadlock victim. The other one succeeds, this one is rolled back. So let's see if we can improve upon this. We'll go back to our startup form, and we're going to put in a little bit of error handling. We're going to look at form with some error handling. Form looks the same, does pretty much the same thing, but we've added some code. We're going to go ahead and once again clear the data grid view, create a connection, open the connection, create our SQL statement, and create the data adapter and the data table. But before we fill that, we are going to wrap the fill statement in a try-catch block. And when we get the error, our application is not going to crash, but it's not going to do what we wanted either. We'll bring back the other copy of the application. This one is the one that was compiled, executable. This is the one that is running within Management Studio. So we'll run this. Once again, I'm going to run them separately to verify that they work when they're not interfered with. And we see that they do. Now, what happens when we run them at the same time? Well, we get the message box from this application that gives us the same error message we saw in the development environment. Well, that's good. Our application doesn't crash, but it doesn't do what we wanted either. Let's try yet another approach. We'll come to our startup form and see that we have yet another form with better error handling. Looks the same, but we're going to have something here that tells us what the deadlock count is. How many times it has to go through the loop, similar to what we saw in our transact SQL script that had a loop. So we have a form with better error handling. We're going to set our deadlock count equal to 0. We're going to do everything all the same until we get down to our try catch block. In this case, we're going to put a loop around the try catch block. We're going to let it execute up to 10 times. And the reason we need to limit it, rather than just let it execute forever until the break occurs, is that it might not execute for some reason other than a deadlock. There might be a permanent blocking activity going on in there, and we don't want this to run forever. As a matter of fact, we might even want to put some code in here that says if I is equal to 10, there's a message box and actually I think I'm going to bring this and put it down in the exception handler so that we can then go ahead and concatenate the error message. In that case, we need to put a variable here. Now, this shouldn't happen, but we're assuming here that the reason it doesn't complete is because of a deadlock, which may not be the case. There's actually ways we could test for that, but I'm going to pass on that for just a moment. So we're going to go through here. If we get an error, we're going to increment the deadlock count and post it to the text box. Do events, because otherwise it's not going to update until the end. Get rid of our message box, because that would stop everything. And go through the loop until it succeeds. So now we have both of these. We're going to take our first SPID, first connection. SPIDs actually correspond to connections. Connections are sessions. And then we're going to do some better error handling. And run the update. Let's run them separately again. I like to do that, always to verify that when it runs, it does what I want it to, without interference. And it does. Now we'll try running them at the same time. And we'll see that this one ran in about 3 seconds, this one ran in about 6, which is kind of what we expect. Notice that it records the deadlock count 1. Now we had that issue of it might fail to execute for multiple reasons. I paused the video recording and started it again after I added some additional error handling code in the same place that we had error handling code for the third form. Notice we try, and if there's a failure, we now have 2 catch blocks. If we have multiple catch blocks, what we want to do is put the specific before the general. Since SQL exception inherits from exception, it is more specific. And if it's caught here, it doesn't execute the second catch block. So we have a SQL exception, and the SQL exception has a property that the exception object doesn't have. It's exception number. Now, what is a SQL exception number? If we go back and look in Management Studio, where the update failed, we'll see that it told us that there was a deadlock, but it also gave us a message number, and this message number turns out to be the error number or the exception number. So we can go back and say that we can test if the exception number was 1205. We can then take actions based on that. Now, it might be a SQL exception other than that. Perhaps our connection is broken. We can give back the number, and we can also give the message that was generated at the time. If this fails for some other reason, then we can capture that exception. This block does not execute, and it will go ahead and give us a message there as well. Let's see how this works. Let's make sure that it still runs properly when there's no contention. And now let's see what happens. It runs the same as before. Now, in this example, I've gone ahead and given it an opportunity to run 10 times. In almost all cases, the code associated with the first connection should have been written that regardless of what it does not take long to execute. So it should really only take one retry. I added some additional ones, probably too many. If you do put it in a loop, you must be sure to put some sort of termination in it. In this case, it can only execute a maximum of 10 times. I've gone ahead and made one more modification to the application in order to look at this second catch block. I've gone ahead and set the connection equal to null so that we can simulate perhaps the connection being broken. And I discovered when I was running this that I made one of the two most common programming errors, the off by 1 error. So I had to change these to 9 and discovered something else. I expected incorrectly that the connection being broken would be a SQL Server error. It's not, because SQL Server can't return an error if there is no connection. So let's look and see what happens. We don't need to run both copies of the application because this is going to fail for a non-blocking reason. We'll look and see that the connection was not properly initialized. We saw that I is 9, so it went through there 9 times. And so we've tested the other part of our error handling code. The broken connection could not be a SQL error because SQL Server can't send back a message when the connection is broken. Actually, there's one more test we can make on our code, and that is to remove the line that sets the connection to null and delete the table on SQL Server. So at that point, we have a SQL statement that we're sending that is syntactically correct but generates a runtime error because the table doesn't exist. Let's see what happens then. And we do get a SQL Server error. We get a SQL Server error number, and it tells us that the table doesn't exist. I hope this has been helpful to you. If you like the video, please like it, comment, subscribe, and share. That will help out attaining some popularity with this channel. Thank you.